All right, we're about to go on a journey deep, and I mean deep, into our planet to find its biggest, oldest, and honestly most surprising store of carbon. It's a story that unfolds over millions of years, and it's hidden right under our feet.
So let's just dive right in. Take a second to think about it. Where is most of the Earth's carbon? Is it in all the lush forests and jungles of the biosphere? Maybe it's in the vast, deep oceans. Or is it floating right above us in the atmosphere, the air we breathe? Well, surprise, the answer is actually none of the above. It's something else entirely, on a scale that's just hard to even imagine. By far, and it's not even close, the vast majority of our planet's carbon is locked away in rocks, in the Earth's lithosphere. I mean, this massive geological reservoir completely dwarfs everything else. And understanding this hidden carbon cache, it's the first step to fundamentally changing how we see our planet's entire climate system. It's that big of a deal. The sheer quantity is just staggering. We're talking about millions of gigatons of carbon. Now, to put that in perspective, 1 gigaton is about the mass of all the land mammals on Earth. Now, try to imagine millions of that, all stored right beneath our feet. It's a truly planetary scale. So the big question is, how did it all even get there? Well, for our first stop, we're heading to the ocean, where we'll see how life itself creates a massive, and I really do mean massive, carbon sink. You see, it all starts with these tiny but mighty marine organisms. Think about plankton, shellfish, and corals. They're essentially living rock factories. They literally pull dissolved carbon right out of the seawater to build their hard shells and skeletons out of calcium carbonate. So what happens when they die? Well, their shells rain down onto the ocean floor. And over millions of years, layers upon layers build up. The weight creates this immense pressure, and minerals act like glue, cementing the particles together until, bam, they're transformed into solid rock, like limestone. And this is where it gets really incredible. This shows the mind-bending power of geology. That same limestone that was formed at the bottom of the sea can be pushed up by tectonic forces to form the world's tallest mountain ranges, like the Himalayas. It's a perfect, visible record of how carbon gets locked away. But believe it or not, that's only half the story. There's another pathway for burying carbon, and this one creates a kind of buried treasure. The secret ingredient for this second pathway is a lack of oxygen. In places like ancient swamps or on deep ocean floors, dead plants and animals just don't fully decompose. The normal process of decay gets slowed down dramatically. So, over millions of years, this undecayed organic gunk gets buried deeper and deeper. The intense heat and pressure from above basically cook it, transforming it into carbon-rich rocks like shale, and eventually into those concentrated hydrocarbons we all know as fossil fuels: coal, oil, and natural gas. So, let's just recap. We have two major pathways for locking carbon away in the Earth's crust. There is the carbonate path, built from the skeletons of marine life, and then there's the organic path, built from the preserved remains of ancient plants and animals. Two totally different sources, but the same result: long-term carbon storage. Okay, let's zoom out now and see how these incredible stores fit into this majestic planetary scale cycle. Because this isn't just about locking carbon away forever. It's all part of a slow, steady, balancing act. Yeah. This is not a one-way street. Nature has its own very, very slow release mechanism. Over millions of years, things like volcanic eruptions and the chemical weathering of rocks gradually release the stored carbon back into the atmosphere. It maintains this delicate long-term balance. You can almost think of it as the planet taking a very, very slow breath. And now, we've arrived at the climax of our story. This ancient, slow, and balanced cycle has recently met a new, incredibly fast force: us. This is where we enter the picture. We figured out how to get to that buried treasure, those fossil fuels, and by digging them up and burning them, we are totally bypassing that slow, natural release. We're putting ancient carbon back into the atmosphere on a dramatically accelerated timescale. I mean, just look at this mismatch. It's staggering. We're compressing a process that nature takes millions of years to complete into the span of just a couple of centuries. That is a profound change to a fundamental system of our planet. Maybe the best way to think about it is like this. Nature spent eons, millions and millions of years, slowly charging a massive geological battery with carbon and solar energy. And we've just found a way to discharge it almost instantaneously. And that leaves us with a really profound question, one that connects this deep geological story directly to our lives today. By understanding the sheer scale and time frame of this hidden carbon cache, we can really start to grasp the significance of unlocking it. The story of rocks has become our story.